Good morning to everyone. I'm Dr. Sumi MS. The topic of my today's presentation is Analysis of Asynchronous Sequential Circuits of Unit 4 State Machine Design of Digital Logic Circuits and Design. On completion, the students will be able to define asynchronous sequential circuits and make an analysis of asynchronous sequential circuits. An asynchronous sequential circuit does not have a clock signal. The transition between different states occur with respect to the input change. This makes them suitable for applications which involve low power input or when a clock signal is not at all needed. In an asynchronous sequential circuit, each flip-flop has a different set of inputs and outputs, and the state of the circuit is determined by the output of that flip-flop. The state transition function, which is a Boolean function, describes the behavior of the circuit and it determines the next state of the circuit based on the current input and the previous state stored in the flip-flop. Asynchronous sequential circuits are used in digital systems to implement state machines, which are digital circuits that change their output based on the current state and the inputs. They are commonly used in applications that require very low power consumption or where a clock signal is not available for use. Analysis of asynchronous sequential circuits. Asynchronous sequential circuits can be constructed with the help of latches. So here with the help of SR latch, without any external feedback path, an asynchronous sequential circuit can be designed. The feedback path is present within the latch, and the analysis of the circuit with latch will be demonstrated by means of an example from which it is possible to generalize the steps necessary to analyze other circuits from this. Procedure to analyze an asynchronous sequential circuit with SR latches. Label each latch output with yi and its external feedback path if available with small yi. Derive the Boolean functions for the set and reset inputs. Check whether SR is equal to 0 and S bar R bar is equal to 0, that is for NOR and NAND latch is satisfied. Evaluate the output Y for both the NOR and NAND latch. Construct the transition table for the output obtained. Circle all the stable states. So this is a diagram representing the example of a circuit with SR latches. Here there are two inputs x1 and x2 and two external feedback loops are giving rise to the secondary variables y1 and y2. First we obtain the Boolean function for S and R inputs in each lab. Then we check under the condition that S and R are equal to 0. And the following transition table is obtained for the above expression. The result is 0 here because x1 bar is equal to x2 bar is equal to 0. The next step is to derive the transition table of the circuit which we have obtained here, and this specifies the value of y as a function of x and y, x1 y1 x2 y2, and we can obtain the excitation functions from the relation of y. Design procedure. Obtain a primitive flow table from the given design specifications. Reduce the flow table by merging the rows in the primitive table. Assign binary state variables to each row of the reduced flow table to obtain the transition table. Assign output values to the dashes associated with the unstable states to obtain the output maps. Simplify the Boolean functions of the excitation and output variables and draw the final logic diagram. Quiz questions on analysis of asynchronous sequential circuits. What do you mean by asynchronous sequential circuits? How do you analyze asynchronous sequential circuits with SR latches? Thank you.